Hey everyone, Chang here and welcome to my channel. Now, in the previous few videos, I focused a lot on word problems. Now, as fun as word problems are, there are some that I guess you could say is as fun as watching paint dry. You guys can guess on that. So today we're going to focus on something different. We're going to focus on numbers. Actually, we're going to focus on a ton of numbers. And start it off with this right here. That's what we're going to do, right? This is going to be focusing on first and foremost, let's just start off with arithmetic sequence. Well, arithmetic and then sequence. Let's focus on sequence first, right? Sequence is basically a list of numbers, usually in some form of a pattern, but usually it's a list with commas separating each and every single term, right? So for example, here's the first one. This is the first term, second, third, fourth, fifth term, so on and so forth. Continues on forever, right? Same here. Notice that it doesn't have to start with 1. It can start with any numbers. Here we have 7 as our first term, 9 as our second term, 11 as our third, and so on and so forth. Here is our first term, right? Second, third, fourth, so on and so forth, right? And here's another one. Well, guess what? Just because the first term is 1 doesn't mean the second term can't be 1 as well, right? It doesn't have to always be different. This one is another sequence. Now, arithmetic sequence is basically sequence, but with a little twist. It actually requires a specific set of condition, right? The condition is that the difference between the term and the next term is always going to be the same. That's why they call it a common difference. So arithmetic sequence always have to have a common difference. So let's look at the first one right here. We can see, hopefully immediately, that the difference between the first term and the second term is just 1. Okay? The difference between the second and third term is just 1. Third to fourth, 1. Fourth to fifth, 1. And theoretically, if you continue on, the common difference should still be 1. So, since it does have a common difference, this is our arithmetic sequence. Arithmetic sequence. And I'm lazy, I'm not going to spell it out. Okay, cool. Well, let's look at the second one. Here we know the common difference, or well, we know the difference, we don't know if it's common, right? But we know the difference here is 2. Excellent. From the second to the third term, 2. All right, looks promising. Third to fourth, 2. Fourth to fifth, 2, and theoretically it continues on. So this is also an arithmetic sequence. So AS. Okay, well, let's look at this one. It looks like it is. Difference is 5. Difference is 5. Difference is 5. Great. Difference is 5, and theoretically continue on. This one, the difference between these two, 0. Okay, so if it's an arithmetic sequence, it should always be the same, right? Difference between these two, 1. Difference between these two, 1. Okay, difference between these two, was that 2? The difference between these two is 3, so on and so forth. So even though this is a sequence, clearly there's no common difference. So this is not an arithmetic sequence. Now, there are two other categories. There's geometric sequence, and one that basically means that it doesn't fall into either or. It's not going to be an arithmetic sequence or a geometric sequence. So those we're going to focus on in another video. Today we're only focusing on this and arithmetic series. Now, when we're talking about arithmetic sequence, there's only actually 2 questions they can really ask you. The first one is that if they give you a specific pattern, something like this, for example, here, they give you the first 5 term. They'll ask you something crazy like, what is the 50th term or the 101th term? And then you have to find the answer to that. So that's a common way of asking arithmetic sequence. The other one is that they'll give you 2 random terms, and then they'll ask you to find the common difference in that sequence. So for example, they'll say that they'll give you the 11th term, and then they'll give you the 57th term. And they say, all right, those are the 2 terms that I can tell you. Now, what is the common difference such that by the time you get from the 11th term to the 57th term, they're always going to be, using that common difference that much number apart. So that's the second type of question that arithmetic sequence you will encounter. So let's talk about those two. So for the first type of question, we have these. What is the nth term in a sequence? Now, they're not going to normally say nth term, right? Nth term means that they just want a formula. usually they're going to put in some number there. It could be the 5th, 7th, 100th, 1000, doesn't matter. So what happens is that when you encounter this, they actually have a formula that you can quote memorize, right, to help you solve it. This is the formula. A sub n equals a sub 1 plus parentheses n minus 1 times d. Well, let's talk about this. A sub n and a sub 1. Now, don't be afraid when you see something like this. Keep in mind they are just variables. That's it. The only reason they use the sub n, sub 1, so on and so forth is so that you can keep track of what kind of variables it is. Well, so for example, if we're talking about the 7th, right, this would, instead of being a sub n, it's going to be a sub 7. And then if it's the 100, it's going to be a sub 100. A sub 1 means that we're just talking about what the first term is. So for example, if I have this particular sequence, right, our a sub 1, our first term is going to be 4. So you would just plug in 4 there. Now, you have the n minus 1. Remember, n is just the term. So if it was the 4th term, then it's going to be 4. If it's the 10th term, this would be 10. If it's 100, this would be 100, right? D is the common difference. Remember, we're working with arithmetic sequence, so there's always going to be a common difference. Now, you can memorize this, and it will be super wonderful if you do. But I actually think that if you know why this formula came to be, right, understand what it's basically doing, it's a lot easier than trying to memorize it, because you can just sort of come up with it just by reasoning things out. And I love reasoning things out instead of trying to just hardcore memorize things. Let's use this example to come up with something similar to this formula. All right, well, we're going to start off with here. This is our a sub 1. A sub 1, our first term. Okay, we know that the common difference, at least we can see right here, is 3. Cool. That's not bad, right? So that would give us our d already. Now, we know that it's always going to be 3 every time. Well, we also know something else, right? From here to here, right? That's technically one difference, right? So from our first, let's just do first to second term, right? That's one difference. Well, from our first to third term, right? So it's going to be 1 to second, then to third. That's actually 2 difference. First to fourth term, right? That's going to be 3 difference, and so on and so forth. Which is awesome, because guess what? What that means is that if I wanted to find whatever term I want, all I need to know is what the first one is, and we know the common difference is going to be whatever it is, and we just have to add it that many times. Well, from this pattern, we realize that whatever term we're talking about, the difference, the number of difference is only 1 less, right? If it's the second term, there's only 1 difference. If it's the third term, it's only 2 difference. Fourth term, 3 difference. Fifth term, 4 difference. That's where this comes in. So if we think about it this way, our initial term, all right, 4, plus our common difference is going to be 3, and we want to figure out how many times we have to add 3. Well, it depends on what term we want. If we want 10, right, we actually only have to add 3 9 times, because we have our initial one and then keep on going. If we want the 30th term, we only have to add 3 29 times. So there we go. This is basically the number of times, or the number of difference. And that's all this formula is. It's basically whatever term you want. It's basically you start off with this, you figure out what the common difference is, and you figure out how many times you have to add them. And depending on what term you're talking about, it's basically 1 less that term. So once again, from this pattern, as long as you get that, whatever that term is, it could be the 1000 term, then all you have to do is just add 999 of those common difference, and you would get that final term, right? That's where this formula comes from, and hopefully this would help you, right? So if you don't remember this right away, you at least can reason things out. You can also brute force it and just keep going. Let's just hope and cross our fingers not the 10,000 term where you're going to be adding for a while. But hopefully by then, after maybe, I don't know, 30, you start to intuitively come up with something similar to this and then make your life a little more easier. Now, the second type of question is this one. What is the common difference? Now remember, this is usually the case something like this, where they give you like two terms, and the two terms are not right next to each other, or it's going to be a piece of cake to solve it. They're usually pretty far apart. And then they ask you what is the common difference, such that, well, basically remember, common difference is that from one term to the immediate next, right, there is that difference number, and is always shared as you move on to the next term. Well, let's say, for example, here we have the third term equals 18. That's usually written in like a word problem format. In an actual equation format, they might just give you something like this. A sub 3 equals 18. And then the 11th term is 44, or A sub 11 is 44. And they ask you to find the common difference. Now, the lovely thing about arithmetic sequence, and this only works with arithmetic sequence, is that remember, there's that common difference. They are always going to be the same. So, if that's the case, where does this formula come from? This is one where they want you to memorize so you can always find a difference. But guess what? Just understanding the concept of the sequence and how the common difference plays a role in it, we can sort of ignore or realize where this comes from. And it's not as complicated as it looks. D equals A sub y minus A sub x over y minus x, where y and x is basically whatever term. In this case, our y is going to be our 11th and our x is going to be our 3rd. Now, before we just even talk about this, let's just see what we're doing. Well, first and foremost, we want to find the actual difference, right? Not just the common difference, like the large difference between this and this. So if that's the case, we're going to just do 44 minus 18. That gives us the actual difference. Actual difference. Okay, cool. Well, 44 minus 18 is what? 34 minus 8 is going to be what? 26. Okay, cool. Now, afterwards, well, we don't want just the actual difference. With the actual difference, we figure out that large length of a difference. We want to cut it into chunks. So that basically, between each term, they share that same chunk, that same common difference. Well, if that's the case, we know that the 11th term is the larger one. Then it's the 3rd term. So if we get this one and we subtract this one, we have that chunk. So 11 minus 3 is equal to 8. Okay? So that tells us basically how many terms are in between. How many terms are in between? And just like that, we have the total actual difference. We know how many terms are in between, so if they're going to be equal, all we have to do is take the total difference, the actual difference, divided by the number of terms. So 26 divided by 8 equals what? Was that 3? And then you have, that's 0.25, I believe. 3.25. Okay? And there you go. That's your common difference. Notice that basically what we do is similar to the actual formula or equation itself. We took the actual difference, which is basically that, right? You get the actual number itself minus the other one, the smaller one usually, right? That's the actual difference. And then we divide it by how many terms there are. Well, how do we find out how many terms? Well, we get the larger number of term minus the smaller number of term, and that gives us how much is in between. And just like that, we get our actual common difference. So, yes, formula's nice. Intuitively, makes a whole lot of sense. We can just reason it out. We don't have to memorize that. Alright, so moving on to arithmetic series. Now, it seems scary. Actually, when you look at it, it is quite scary. But here's the difference between arithmetic sequence and arithmetic series. Arithmetic series is just basically a sequence, but instead of being separated by commas like the previous one, right? We're actually just adding them all together. So, for example, this is an arithmetic series, right? Instead of 1, 2, 3, all the way to comma 100 and so on and so forth, now we're saying we're going to have 1 plus 2 plus 3 and so on and so forth. The other thing is that usually arithmetic series, not always, but usually it ends. right? Unless you move on to like calculus and stuff and then they start playing with the whole infinite and so on and so forth. Yeah, usually it ends, and that's the wonderful part. The other thing is that because it's all adding, right? There's really only one type of question they can ask you. What is the sum of all that? Right? What is the sum of that entire like series? That's it. So that's why there's usually only one formula that they want you to memorize, which is something that's super scary in and of itself, right? You have a sub 1 plus a sub 2 plus dot 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 plus a sub n equals n divided by 2 times parentheses a sub 1 plus a sub n. What the hell does that mean? Well, I think the best way to do is not memorizing this is okay. Although I feel like if you don't truly understand where this comes from, trying to memorize this is just going to drive you up the wall. So hopefully with this classic example of a series addition problem, right? I can use this and show you why this works. Okay, first and foremost, let's just assume 1 all the way to 100 is just basically this side right here. A sub 1, and it's going to be all the way to a sub 100. In this case, it's just all these numbers. Now, in this case, what it would mean is that you have, was the number of terms, well, there's going to be 100. 100 divided by 2 times parentheses of a sub 1, which is going to be 1, plus a sub n, which is going to be a sub 100. In this case, it's going to be 100. So it's going to be 100 plus 1, right, times 100 over 2, or 50. And that would be your answer. But why the heck does that work? Well, basically, it's using this, like, sort of, I guess you could say, reason. Now, what we're going to notice is that when you add 1, or the first term here, which is going to be 1, and the last term, 1 plus 100 is 101. Cool. Doesn't help that much. But if I add the second term and the one before the last one, 101. Okay, interesting. Third term, and I guess you could say third backwards, 101. And we can keep going, right? The fourth term and the fourth backwards is still going to be 101, right? The fifth term and the fifth backwards is going to be 101. And it's always going to be 101 in that case. Well, okay, now we're getting somewhere. Because guess what? That means that all of them, when you add them, is always going to be the same number. So it's technically equal just to the first and the last one added together. First and last added together. All right. Okay. Now that we got our first and last added together, 101 is what we noticed for this one. How many times do we do it? Well, technically, how many terms are there? There's 100, but we didn't add it 100 times. We actually added by half, right? Because remember, we're just basically taking half of it, right? This plus that, this plus that, this plus that, and then on and on and on and on until we hit the midway point. So if that's the case, 101, right? Times, instead of 100 term, we technically cut it in half because we're adding both sides together until we hit the middle. So we would get the number of terms, but we have to divide it by 2 to make sure it's cut in half. So since we know it's 100 terms, now we're going to divide it by 2, which gives us 50. And just like that, we have basically 50 times 101, which 5,050, I believe. Correct me if I'm wrong. Hopefully that's correct, right? And just like that. That's what this formula is really saying. All it is just using this reasoning. It looks complicated, especially with all the a sub whatever, but it's really not. It's just that I'm going to add the first and last, and just by reasoning, they're always going to be the same. Luckily, because there's always a common difference, right? They're always going to be the same. And then after that, I realized that whatever series I'm working with, I basically cut it in half. When I cut it in half, instead of the number of terms, I'm only using half the terms. That's how many times I'm technically adding that same number together. And then that would give us our answer. Just like that, and that's arithmetic series. Actually, in this case, it's a little more simple than arithmetic sequence. All right, so enough talking. Let's just go and start solving problems. All right, so here's one right here. We are given this wonderful sequence, and we're asked to find a sub 10. Meaning, basically, we're looking for the 10th term. Now, If we're not sure more than anything and it's the 10th term, technically we can just brute force this. We find a difference. We know that this is an arithmetic sequence, so there's a common difference. Well, let's see. Difference between 4 and 11 is 7. That's good. And just to double check to make sure that it is an arithmetic sequence, well, this is also 7 and this is also 7. Okay, so looks like it's going to go well. So if I really wanted to, and I don't know if that's called lazy, but if I just really wanted to, I guess, work through it the brute force way, I just keep adding 7. Total of what? 9 times, and then you would get your final answer, right? Or I could use the formula. Now remember, this one, since we're trying to find the nth term, right? The formula itself would be a sub n equals the initial term a sub 1 plus, and it's going to be n minus 1. Right, it's the number of common difference that you want to basically add or multiply by, and the actual common difference itself. Well, if that's the case, we want a sub 10 equals a sub 1 is 4, our first term, plus, and we know that it's going to be 10 minus 1 times our common difference, which is going to be 7. Excellent. All right, let's start working on this. So a sub 10 equals, what is it going to be? 4 plus, and it's going to be 9 right here, times 7. So that's going to equal to 4 plus 63, which equals 67. And just like that, we already figured out that the 10th term in this sequence is 67. So the next problem is actually a little sneaky, but basically we can solve it no problem. First and foremost, we're given the a sub 20, basically our 20th term, is 10. A sub 50, 50th term, is 70. Now it's asking you something a little odd. They're asking you for a sub 40, which is the 40th term. Now how the heck do we go about this? Well, the best thing we can do is first and foremost just find the common difference. Then we can work from there, right? At least we know what the common difference is. That'll tell us a lot. Well, the formula for this is the second one, right? Because we want to find the common difference. So it's going to be d equals a sub y minus a sub x over y minus x. And remember, if you don't remember the formula, that's fine. We're just going to try to find the total difference and divide it by the total number of terms so that it gives us each individual common difference. So 70 minus 10, and what was it? It was our 50th term minus our 20th term. And that's basically using this formula as well, right? So what is that? 70 minus 10 is 60. 50 minus 20 is 30. Simplify this, 2. So this is our common difference, right? Our common difference is 2. Okay, we're getting somewhere. Okay, cool. Now what else can we do? We can actually use that formula again. Let's try it again. So d equals, and we can actually use either one of those two, right? But let's just say for the sake of, I don't know, whatever, my choice, right? I'm going to use a sub 50, right? So a sub 50, or the 50 term, is going to be, what is it? 70 minus, and now instead of a sub 20, we don't care about it, we want a sub 40. So we're going to keep it as a sub 40 because we don't know what that is and we're looking for that. Well, we know that that's our 50th term, and then a sub 40 is our 40th term, so we're going to subtract those guys. And instead of d, now we know what d is, and that is our 2. Excellent. All right, cool. So, well, that means 2 equals 70 minus a sub 40 all over 10. Multiply by 10 on both sides. This goes away. You have 20 equals 70 minus a sub 40. Okay, and with the little mumbo jumbo algebra magic, you move this one this side and that one over just to get rid of the negative sign. So I'm just going to add a sub 40 here, add a sub 40 here. This goes away, so now I have a sub 40 plus 20 equals 70. And then now I'm going to subtract 20 here. This goes away, subtract 20 here. Now I have a sub 40 equals 50. right? And just like that, we have our 40th term. All right, so let's talk about this problem. Now, this problem is actually a pretty scary problem. It's clearly a series problem, right? But keep in mind that usually when we're dealing with series, at least with the example I showed you, or the formula itself, you kind of need to know the number of terms. Well, this one doesn't actually tell you the number of terms, which makes it a tad bit more difficult. But here's the key. Remember that series and sequence are basically very related, except for that sequence is separated by commas and series is separated by, well, not separated, replace the comma with addition signs. Well, they're still arithmetic. That means they still share a common difference. And with that, we can actually find the number of terms, right? And if we know the number of terms, then we can solve it very easy. So, first and foremost, since they have a common difference, we can think of it as a sequence if that helps us. The difference between these two is 16. Okay, good. So we already have 16. We don't know what the number of term is, but we can actually use this formula right here. So we have a sub n equals a sub 1, right, plus n minus 1 times d. Right? Because this, guess what? We have almost all the information. The only thing we're missing is the n, and that's what we're looking for, right? The reason we have this is because this usually means the end of the sequence or term, right? That's that. So we just put, instead of a sub n, now it's going to be 263 equals a sub 1 is our first term, 7 plus n minus 1, we don't know what that is, but we know the common difference is going to be 16. 16. Cool. Now we can work with it. So, what happens? Let's see. If I subtract 7 here, that gives me 256 equals 16 times n minus 1. Okay, getting somewhere. Divide by 16 on both sides. And if I remember correctly, 256 divided by 16 is 16 equals n minus 1. Cool. Plus 1 plus 1. So, n equals 17. This is our 17th term. Okay, cool. Now, we can actually use the quote-unquote formula. Remember that the sum of all this is just going to be, what is it? N divided by 2 times a sub 1 plus a sub n, or the first and last term. Well, let's see. We know that n is going to be 17. Now it's just going to be 17 over 2 times a sub 1 is going to be 7 plus a sub n, 263. Excellent, we're getting somewhere. Let's see, that's 17 over 2 times 270, which if we simplify is just basically 17 times 135. And what is that? That's 1350 plus 7 is going to be what? 53429. And just like that, we have, what is it, 5922. 2,295. So the sum of all this number is 2,295. And just like that, remember, even though this was a series, right, we use some understanding of sequences because they're both arithmetic, and series is just addition of all the different terms in a sequence, and that helped us. We needed to know one thing. How many terms? 17, because we use the information from sequences, figured out it was 17, then we can use the formula or just reason our way out and figure out what the final answer is. Alright, so with that, hopefully I've demonstrated, or we've come to the conclusion that there are certain formulas that by memorizing it actually becomes more difficult if you don't understand where it comes from, right? I'm not saying to be able to prove every single formula before you use it, but at least by understanding conceptually where it comes from, why it came to be, right? It makes sense a lot more. You don't actually end up memorizing it because you already understand what the purpose of it is. And if you can reason through that, then everything is good. Now, other formulas that does require extensive, like 20,000 page proof, just memorize it. Don't waste your time on that, right? Yes, some guy in the past probably won some award. That's why their name is probably on it, just because they proved it. But other than that, you don't need to memorize that. It's sort of trying to like reinvent the wheel. Not worth it. So hopefully this makes sense, right? Arithmetic sequence, arithmetic series, not so bad. Yes, 3 formulas that you can quote unquote memorize or just reason it out, right? Thank you again for watching. See you in the next video.